Water. It's all around us. In streams, the rain, our kitchens, and of course, in our bodies. Most people know that water is essential to life, but not everyone knows why. What is it about water that makes life on Earth possible? To answer this, we need to get a better understanding of water. Water in its molecular form is made up of an oxygen atom and two hydrogen atoms. If we look at the oxygen atom, we can see that its valence or bonding capacity is 2, and that it has two other pairs of electrons not used in bonding in the valence shell. In the normal state, the electrons in this valence shell rotate in the 1,2s and 3,2p orbitals, but when an atom forms covalent bonds, the orbitals in the valence shell rearrange and form a tetrahedron, so that the bonding electrons and unshared electron pairs can be as far away from each other as possible. Therefore, when hydrogen bonds to these electron pairs, it is not in a linear form, and this is what gives the molecule its bent shape. Because oxygen is more electronegative than hydrogen, it pulls the shared electrons towards it. Hydrogen is unique in that it has no other electrons to shield the proton in the atomic nucleus, and so the hydrogen end becomes more positive, and the oxygen end becomes more negative. Water is polar. Because water is polar, it is able to dissolve much more substances than any other liquid, and can dissolve most polar and ionic substances, unless the molecules are too large, in which case it becomes a colloid. The charged poles of the water molecules attract the oppositely charged molecules of the polar or ionic substance, separate the molecules, and shield them from each other. This is why water is known as the universal solvent, even though it is not really so. Our cells are able to function because blood carries important minerals, sugars, and micronutrients to them. These nutrients are dissolved in the plasma, which composes 55% of our blood. This is able to happen because plasma is 90% water, and due to water's outstanding abilities as a solvent. The oppositely charged parts of the water molecules attract each other. The slightly positively charged hydrogens are attracted to the slightly negatively charged oxygens, and bonds are formed between them, known as hydrogen bonds. Hydrogen bonds are responsible for many properties of water. Hydrogen bonds account for a unique property of water. Its solid form is less dense than its liquid form. This is because when water is in its solid form, ice, its molecules do not have enough energy to break the hydrogen bonds, and so the hydrogen bonds are locked, and form a shape called a crystal lattice, where each water molecule is bonded with 4 partners. This keeps the molecules further away than they would be in the liquid water, where bonds are constantly breaking and reforming. In lakes and other smaller bodies of water, when water freezes, it becomes less dense and so floats to the top of the water. This means that it serves as a sort of insulating layer, which allows life in the water to live without freezing to death. If it were not for this property, then the ice would sink to the bottom and expose the water above, freezing it from bottom up and killing all marine life. Cohesion refers to the attraction between water molecules due to hydrogen bonding. This accounts for transpiration, which is the main method which plants utilize to transport water up the plant against gravity. As the water is evaporated at the leaf surface, more water is drawn up due to the pull on each water molecule that travels down the tree. Furthermore, cohesion is what causes the surface area of water to be minimized compared to its volume. Water molecules on the surface of a liquid are attracted to the molecules inside the liquid by hydrogen bonds, but they are not attracted to the air above the surface of the water. Therefore, water droplets are often in the shape of spheres. Spheres are the shape that have the smallest surface area in comparison to the actual volume. This allows rain to fall in droplets that are held together in their spherical form. The cohesive nature of water further makes water have a greater surface tension than other liquids. Insects such as the water strider are able to walk in water due to this property. In addition to cohesion, the attraction between like substances, there is also adhesion, which refers to the attraction between water molecules and non-water molecules, and can be seen when one looks at the meniscus of a measuring cylinder, which is always slightly curved. Adhesion also helps pull water up plants. Because of the hydrogen bonds between water molecules, water is able to store great amounts of heat energy. When the temperature rises, most of the heat goes towards breaking hydrogen bonds, and so only a minimal amount of heat can go towards making the water molecules move faster, and the water molecules must move faster for the temperature of the water to rise. Hydrogen bonds take heat to break, and so when they reform, they release heat. When the temperature of the atmosphere drops, hydrogen bonds reform, and this releases a lot of heat energy, which keeps the temperature of the water relatively stable. Therefore, the amount of heat that must be absorbed to change the temperature by 1 degree Celsius is high for water. This means that the aquatic environments have a largely stable temperature, and this is what allows the organisms that live under the sea to thrive. If water were susceptible to temperature fluctuations, it would be much harder for the same organisms to live underwater. Furthermore, the fact that water does not change temperature much allows us to journey into a wide range of climates. Since our bodies are largely made up of water, the relative stability of water allows us to expose ourselves to a wide variety of temperatures without endangering our body. For the same reason that water has high specific heat, it also has high heat of vaporization, so a large amount of heat has to be absorbed for it to become a gas. Sweating cools us down because it requires a lot of our body heat to evaporate the water. So in conclusion, we have seen that water is polar, giving it its reputation as a universal solvent, leading to its many uses in our bodies. The polar molecules bond to form hydrogen bonds. Because of hydrogen bonds, water is less dense as a solid and floats on lakes to insulate them. Hydrogen bonds also cause cohesion and adhesion, which together cause transpiration to occur and pulls water up trees and plants. Finally, hydrogen bonds help regulate temperature, and water has a high specific heat, allowing large aquatic bodies to have stable temperatures throughout the year. On a related note, it also has a high heat of vaporization, allowing our bodies to cool down when we sweat.